Okay, so welcome back, everyone. Uh, Today we'll be looking at the rest of the problems that we started yesterday, and hopefully we'll be able to solve most of them, so you guys can get a chance to ask questions if you have any. Right. So, like I said again, multiple times before, feel free to stop me at any time during the session to ask questions if you do have any. And hopefully, maybe if we finish early, we can take some time at the end to address any of those questions. Right. Okay. So next problem that we're looking at here is the integral of ln x squared, right? Or rather, I should say ln x all squared, right? And as we've seen before, this is a case where we have to think about using either u-substitution or maybe integration by parts. So in your opinion, can u-substitution help us solve this problem? Or is integration by parts a better option? And if it is, what would you suggest to use u as and dv? I'm asking you guys. I want your input. What do you think? Should we use some sort of u-substitution to try to simplify the expression? Because as we know, we can't easily find the integral of ln x squared, right? So we have to use some sort of substitution, right? So now we have two options, either u-substitution or integration by parts. Which one do you think we should use here?
U-substitution.
Right. And if we do, what should we substitute u with? So what type of u-substitution should we use?
I think we should substitute ln of x.
So let's try that. So let u be equal to ln of x, right? So that would mean that du is equal to, right, 1 over x dx, right? Meaning that dx is equal to x du. Now, bringing it back to the expression, we have the integral of therefore u squared, and dx is just x du. And since we know that u is equal to ln x, that means that x is just equal to e to the u, right? So now we have the integral of u squared multiplied by e to the u du, right? Which gets us to this point. So at this point here, how should we move forward? Because now we have the product of two functions, right? And this product of two functions can be solved any number of ways, but what do you think we should do at this point here? Excuse me, can you repeat that again? Integration by parts. Okay. The audio is a bit shaky there, but I think you said integration by parts. So if we use integration by parts, and in this case, let's just use f and dg, right? So there's no confusion with the u that's already there. If we use integration by part at this point, what do you think we should use f to be And what should dg be? Again, that's my question to you.
F could be E raised to
Right, sorry. You said f could be e to the u and dg would be u squared, right?
yes.
Okay, let's try that. So dg will be u squared times du. So then df would be e to the u, right? We know that's the derivative of e to the u. And then g would be the integral of u squared, which is just u cubed over 3, right? So we have that. Now let's see if it helps us. It would be, the formula tells us that it has to be f times g minus the integral of g times df. So f times g gives us e to the u times u cubed over 3 minus the integral of g df, which is e to the u times u cubed over 3 du. Right. So now, at this point, we have to solve this as well separately. And the other methods that makes more sense would be, again, integration by parts, right? So I hope you guys agree. Okay, so let's take it. Like I've mentioned multiple times before, guys, this is a trial and error, right? So we're trying to see which methods gets us to the solution. So let's keep going and let's see if it gets us to the solution. So we have to do integration by parts again, meaning, and to stay consistent, we have to let f be the exponential again. So f has to be e to the u, and dg has to be u cubed, right? So let's take out the 1 over 3 there as a constant, u cubed du. So our g will be now u to the 4 over 4. Our df will be e to the u du. And using the same formula, we have f times g, so e to the u multiplied by u to the 4 divided by 4 minus the integral of g df, which is u to the 4 divided by 4 multiplied by df, which is e to the u du. So now, as you can see, right, we just end up getting another integral to solve by integration by parts, and we are only going high and high in order, right? So we are getting in higher orders. We started with a square, now we went to a cubed, now we're going to a 4, right? In the exponents, which doesn't make our job easy, because in a question like this, you would only have like maybe 10 minutes to spend on it in a test or an exam or anything like that. So you do not have, and it doesn't seem as if integration by parts gets you to the answer, right? Or at least this gets you to the answer. So, oh no, not integration by parts, but I mean u-substitution, because that's the original thing that we did, right? So we did use u-substitution originally. So let's try to use another method then. We remember that the original question is the integral of ln x squared dx. So since u-substitution didn't work initially, let's try integration by parts at the first step, right? So let u be equal to something, and let our dv be equal to something. So in your opinion, right, what should u be? What should dv be in this case? Again, I'll take you back to what we were mentioning yesterday for those who are here, that you're trying to choose the function that is the easiest to integrate as dv, right? You don't want to choose a function that is very hard to integrate as your dv. So in your opinion, what should be our u and what should be our dv? Keeping that in mind.
Okay. I think our u can be ln x squared and our dv should be dx.
Right, thank you for that. So let's try that. So our u would be ln x squared. Our dv will just be dx, meaning that v will be x, right? And our du will be the derivative of ln x squared, which is 2 multiplied by ln x multiplied by the derivative of ln x, which is 1 over x dx. And that means that dx is equal to x du divided by 2 ln x. Right. So now let's substitute that into the expression. So we have, the formula tells us has to be u times v multiplied by v times du, right? So u times v is x times ln x squared minus the integral of v du, which is x times du, which is x times 2 times 2 multiplied by ln x all over x dx, right? The x can cancel, as we can see, right? So this cancels to be, simplifies to be x times ln x squared minus the integral of 2 ln x dx. Once again, we are left with an integral that we need to evaluate, right? But at least, right, we can already see that instead of going higher and higher in exponents as we're doing before, you know, from u squared to u cubed, right, to u to the 4, now we are going down, right? So we started with a ln x squared, now we're going to a ln x, which is a simpler form. So now we have to do, let me ask you, what do we have to do at this point to solve this integral? What are your suggestions, guys? Come on. What do you think?
Use integration by parts again.
Integration by parts again, right? So, and what should we use as our u, and what should be our dv?
And ln x should be and dv should be 2dx.
Sorry, can you repeat that again? I think there's a lot of background noise there.
U should be ln x and dv should be 2dx.
Right, so let's try that. So our du should be ln x, our dv should be 2dx. So that means that our du will be 1 over x, right? 1 over x dx. And our v will be 2x, right? So that means that that integral Right, so this integral 2 ln x dx is equal to u times v, which is 2x ln x, minus v du, so double the integral of 2x times 1 over x dx, which is 2x ln x minus the x can simplify, so there's a 2 left, and the integral of 2 is just 2x, and that should be our answer. Meaning that the integral ln x squared is equal to x ln x squared minus that integral, which is 2x ln x minus 2x, right? And this can be simplified further to be x times ln x squared minus 2x ln x plus 2x. All right. Yeah. So that should be what the final answer looks like. Any questions? Okay, so if you have any questions, you're free to stop me at any time. Right, so let's move on to the next one then. But this one is asking us to find the integral of sine of the square root of x. Right, so how should we go about solving this, in your opinion?
I x sine root x equal to u and dv equal to dx.
Okay, let's try that. So we're using integration by parts. So let u be equal to sine root x and dv be equal to dx, meaning that v is equal to x, right? And du is equal to the derivative of that, which is 1 over 2 root x multiplied by cos of root x, right? Yeah, the chain rule, which you guys should be familiar with. Right, so now that we have that, oh, sorry, I forgot the dx here. It means that this should be equal to u times v minus the integral of v du, right? Which is equal to x times sine of the square root of x minus the integral of v du, which is x divided by the square root, 2 times the square root of x times cos of the square root of x dx, which if we simplify, you can clearly see that you'll be left with, let's write it down, x times sine of the square root of x minus, let's take out the constant, 1 over 2, the root x multiplied by cos root x dx, right? So now we are finding ourselves in a situation where we might have to use integration by parts again, right? So, or do we have to use integration by parts? What do you guys think?
Maybe we can let root x equals to u with u-substitution.
Oh, so we use u-substitution. Let's try that. So integral of the square root of x cos root x dx. Using u-substitution, that would mean let u be equal to root x. Du is therefore equal to 1 over 2 root x dx. And just give me a minute, guys. I'll be back. Just give me a minute. Right, sorry about that. So moving on. So we have our du. Now let's find our dx. So our dx would be, our dx would be 2 root x du. So now let's substitute that. So we have u times cos u, and dx is 2 root x du. So we know that root x is u, so we have the integral of u squared, right? That would be 2u squared times cos u du. All right. So now that we have that, what can we do here further? What can we do to move along from here?
Maybe integration by parts.
Integration by parts, right. So we can use integration by parts. Let's try that. So what should our, let's use f and dg. So what should our f be? What should our dg be? Right, so what do you guys think? We can try, for example, both of these functions are easy to integrate and derive. So let's say, for example, we try f as our u squared. Let's leave out the constant too for now, because it's doesn't affect our integration for now. So let's f be our u squared, and let our dg be our cos u du. That will mean that our df is equal to 2u du. Our g is equal to negative, rather not negative, sorry, is equal to sine u, and that is therefore equal to u times v minus v du, or rather not u, that would be f times g minus the integral of g du. f. Right, so f times g is u squared times sine u minus the integral of g df, which is so 2u sine u df. Oh, sorry, du. So now we're finding ourselves. Yes, you see, as we can see again, we are getting lower and lower in the exponents there. So we can assume that we are going in the right direction. So we have to use a second u substitution for that integral, which let's just consider u sine u du. Or let's put the 2 in so it doesn't confuse us with the other 2 that we already have. So using that substitution, we would have, and we have to stay consistent. So our f would have to be again 2u, and our dg will be sine u du. And that would mean that our df is 2, right? And our g is negative cos u. And this would be equal that f times g minus the integral of g df. F times g is just negative u 2u cos u minus g df, which is the integral of 2 times negative cos u du, right? So this is supposed to be a du here. Okay, so this can be simplified further to be negative 2u cos u, and then the two negatives there become positive, so plus the integral of 2 cos u is just 2 sine u, right? So we have that. Now let's bring it back to the expression there. So in fact, let's go all the way back anyways. So our original expression, right? We did quite a lot. Wow. Okay, so let's take it step by step. First, let's do that. So this one, so the 2 times the integral of u squared cos u du is equal to all of this. So that would be u squared sine u. So u squared sine u minus this integral here, which we just found to be this entire thing. So it will be minus minus, so 2u cos u minus 2 sine u. So now we got to that point here. Oh, we forgot about the 2 there. So there's a 2 here multiplying outside. Right? So, and then going back further to our original u substitution, we know that u is root x, right? So u is root x. That would mean that we have 2 times x sine root x plus 2 root x cos root x minus 2 sine root x, right? Again, and then we have to take it now to this expression here. So the total integral, which is the original question, so the integral of sine root x dx is equal to, we have x times, so x times sine root x minus half of this entire thing, right? half of the integral of that. So that would mean the half and the 2 that will cancel, so we don't even have to worry about that. Minus x sine root x minus 2 root x cos root x plus 2 sine root x. So the x root sine root x will cancel, these two will cancel. We'll be left with negative 2 root x times cos root x plus 2 sine root x. Right, so let's now double check these calculations.